In our last video, we created a scatter plot of this set of data that we had already entered in. This time we want to actually run a linear regression, find the linear regression, and have it graph the linear regression along with our scatter plot. Before you get started, it's always a good idea, because we're going to store the equation in the calculator, it's always a good idea to go up here to y equals and just see what you have in here. If when you do that, it doesn't look like this, that means that you're in a different mode setting, and so you'll just want to hit mode, and it's right here, function, parametric, polar, sequence. So maybe you were doing parametric equations before, or polar equations, or you were plotting sequences down. If that was the case, you just need to change it back to function mode. If that's not the case, congratulations, you're in the right one. So I have an old equation that I had graphed. You can tell that it wasn't graphing because the equal sign is turned off. I can leave it here and then know that I need to store my regression equation in one of these other y's. But honestly, I don't need that function anymore, so I'm just going to get rid of it. And then that way I don't have anything in here interfering, and I can store my regression equation right there in the y1. So now I'm going to get out of here, second, quit. And to get to our linear regression, again, we're going to go back to stats. So we're going to hit that stats button. And now I want it to calculate. I want it to calculate my regression. If you are going to do hypothesis testing, you can skip this and go straight to the hypothesis testing. I should have said that at the beginning. So I want to do a linear regression, the ax plus b. You might be asked to have A represent the y-intercept and b represent the slope. Up here, A is representing the slope and b is representing the y-intercept. I'm going to just do the first one. They give you both the same regression equation. It's just a matter of what does A and B represent. So my X was listed under my L1 and my Y was listed under my L2. You can always change these if they're wrong. The frequency list would be if you had had multiple entries and you had listed them in a third list to say how many of that multiple entry. I don't ever do it that way because I feel like I almost always mess it up when I do that way. So I'm going to leave this blank because I specifically didn't do it this way. Store your regression equation. Okay, so this is the big deal. I said earlier, I want my regression equation here in the y equals. Now I could calculate it and then write it down and then put it in manually by hand. But then I have to decide, well, where am I rounding out to? If I just go to store regression equation, it will auto-store it in here for me. So here's the key. You want to store it under as a variable. So go find your variable button, V-A-R-S. I'm going to hit enter, and I want to store it as a y variable because I want it to be under the y. So I'm going to go over to y variable, and we're working in functions. Remember when I said change your mode, function, parametric, polar? We're going to go to function and hit enter. If you kept other stored equations in here, now is the time to select where you decided to store your equation. I got rid of mine, so I'm going to keep mine at the top at y equals. And then I can just go right down here. So again, what list I chose for, I put my x's in, what list I put my y's in, and then where am I storing it? And we're going to hit enter. Now look at what it's given you. It's given you y equals ax plus b. It's giving you the value for A, the value for B, and because we turned our diagnostic on at the very beginning, if you didn't do that, if you're not getting R and R squared, please go see that video on how to turn your diagnostic on. So what did we get from here? Well, I know that in general, and remember that should be y hat is equal to ax plus b, and from here I can just plug in. So y hat is equal to 0.516x plus negative 4.1877. And that is a rounded version of what I got. My r squared, that is part of your Pearson correlation coefficient. This tells you the percentage of the data, of the y data that's being explained by the line. So about 94% of our data is explained by the regression. And then R, your R value, your R value tells you the strength of your correlation. So I have R will always be between positive and -1. The further away you are from 0, the better your correlation coefficient. Here's the one thing, if you didn't store it and you accidentally hit clear, you have to go through the whole process all over again if you didn't write it down. However, we stored it, and so right up here in the y equals, there it is magically stored away. There's that y. Now notice that this is not the rounded version that I wrote down. This is the full version that your calculator spit out for you. We can go ahead and the equal sign is turned on, so this is ready to graph. Our graph should still be set up from last time when we did our scatter plot. And so we're just going to hit graph. Is it going to show up? Did I not have it turned on? Enter, graph. There we go. It was just deciding to be funny. And there is that regression line. So I can see, oh yeah, nothing quite hits my line. That's maybe the one that's the furthest. That one's probably going to have the biggest residual. Remember, don't look the closer you are to the line. Look straight up and down to see how big your residuals are. So small residual, much smaller residual, fairly big residual, not that big of a residual. So this is now how we graph our line. Come back for the next tutorial to talk about residuals and how to find them.